Joining us from the University of California, Davis, Amelie Gaudin, and she will be talking to us about diverse systems in the California context. So please welcome Dr. Amelie Gaudin.
Thank you. Good morning, everyone. Amelie, I'm an agroecologist working at the University of California, Davis. Thanks for the opportunity to come talk to you about some of our work on soil health in diverse systems there in California. And thanks to Wayne for the beautiful introduction to some of the topics I will talk about. Okay, yeah, it is quick. So I was working in the Midwest before to move to California a couple of years ago, and when I arrived to California, I was actually struck by the diversity of our cropping system. This is a picture taken yesterday on my fly out from Sacramento, and you can see that even in the winter, we have a tremendous crop diversity going on across our landscape. Actually, we have one of the most diverse and valuable cropping systems in the world, 300 to 400 crops, growing continuously throughout the Central Valley. The Central Valley here, you can see it in brown. We have nuts and fruit crops, grape, berries, so a lot of perennial cropping systems. Vegetables, we're leading the nation in terms of lettuce and processing tomatoes, hay to feed the growing dairy industry, and field crops. Now in terms of trends, acreages in field and field crops have largely decreased over the last few years due to the rise in commodity prices and reallocation of very costly irrigation water to perennial crops. So nuts and fruit crops, grapes, and perennials in general have been rapidly expanding. This has been a kind of a double-edged sword. This has pushed agriculture to the limit. Okay, this is the south of the Central Valley. We're pretty much in a desert, and you see almond production pushed to the edge of the Central Valley. We've seen a rapid increase in perennialization of our cropping systems, with very high density almond cropping systems being implemented all across the valley. And I'm saying it's a double-edged sword because it has created some potential concerns about water use and our flexibility with irrigation water supplies. Those trees have to be irrigated all year long. But it has also provided an unprecedented opportunities to build up agroforestry system. We now have a lot of perennials in our landscape, a lot of orchards that we could increase multifunctionalities from. And we also have livestock. From rangeland to dairies, 18 million acres of grasslands, and a dairy production that remained the state's leading commodity and account for around 18% of the US dairy products. Despite this very apparent diversity, systems are intensifying and are increasingly decoupling. The Cheyenne Diversity Index in Yolo County, just around UC Davis, has decreased a lot over the last 25 years. A lot of land in walnut, almonds, tomato, grapes, and the 25 other crops actually are just 18% of our surface area planted. And we have an increased disconnect between forage feed production, animal production, and specialty crop production, especially in terms of recycling of organic material and water. Water is our number one concern: access to drinking water and irrigation water supply. And you see that this disconnect between the specialty crops and dairy industries and livestock production in general can create some problem in terms of water supply, since most of the water used in California is for hay, alfalfa, and in almond and pistachios. California is already experiencing the impact of climate change. We've just came out of a 5-year drought. It's not looking very good for this year either. It still hasn't rained, okay? We have had wildfires followed by mudslides. So drought cost agriculture industry a lot in the Central Valley. We've also have concern about access to drinking water. This is from the Sacramento Bee yesterday. California can't wait longer for clean water. All in red is above limit drinking water. So a lot of communities do not have access to drinking water anymore. Our first environmental concern is water supply. Our second is that our soils are degrading. Almond production in almond are harvested from the floor. They are swept up from the floor. You want a nice, clean, sterile soil, which is not good news for soil health. Irrigation practices. Why grow cover crop in California? Cover crop use water, evapotranspiration. How do we manage it so that, how do we balance this increase in infiltration and water retention with water use from cover crop? California growers do not want to irrigate a cover crop. Then we have food safety concerns, very low adoption of no-till animal integration in our systems. Lettuce production systems are very scrutinized for E. coli, salmonella outbreak. So it's very hard to diversify those systems. And then climate. We're in the Mediterranean climate. We have very low carbon sink, very sandy soils as well. So the government and I've been moving on, and the California Department for Food and Ag started a very aggressive healthy soil program with $7.1 million being distributed to researchers and producers for research and demonstration projects related to soil health, implementation of what we call carbon farming plans, which started in the grazing and grassland communities and is spreading to cropping systems. 13 practices and counting, including silvopastures, are being promoted as part of what we call carbon farming plans. And then ambitious new scoping plans, which has been released and partially funded from the cap and trade money, with the goal of decreasing our annual greenhouse gas emission to the level of 1990 by 2030. With soil carbon sequestration, and recycling of organic matter on agricultural land as a central part of this scoping plan. So soil health is at the center of our preoccupation, and a lot of very good work has been done in California looking at rating fields and measuring impact of management on soil health and the three major pillars, the biological, chemical, and physical properties, using various indicators. In my lab, we've tried to actually go a little bit beyond that and think about what does it do, because it's very hard for growers I talk to kind of grasp, why should I improve my soil health? What's in it for me? Sequestering carbon is not sometimes something that will resonate with them. So we took a functional view to quantify the benefits to grower and the environment. And we found that talking about resilience to stress and input use efficiency actually resonated a lot with growers. So we embarked on 2 projects, and I don't have the time to show you the extent of all the data. But I will show you some nuggets of some pieces of results, and we can talk some more later. So we investigated the impact of soil health on resilience to stresses. The first one being an abiotic stress with resilience to drought and irrigation water shortage. And the second one is to a biotic stress with the leafhopper vector of the beet curly top virus, which is a big problem in California. And this research came about when I was at the University of Guelph in 2012, and this was my trial. And 2012 was one of the driest year of the last 30 years. And here we have a corn crop which is tilled, grown in continuous corn, and one which is no-till, grown with a rotation of 4 crops and 2 cover crops. So you didn't need much statistics to see that there is a difference in leaf rolling and water stress index in those 2 crops. So I went back and worked some data coming out of the ELORA long-term rotational trials. Those long-term trials, as I mentioned this morning, are a total gem. They are very, very important to be able to look at trends over time and look at multiple sustainability and economical outcome of healthier soil. This trial was established in 1980 and has a diversity gradient going from continuous corn to a corn, oat, barley with 2 underseeded red clover cover crop, and 2 tillage treatment, heavy till and conservation tillage. So soil health metrics are very different between those treatments, with difference in soil organic carbon and organic matter, with much more potential as mineralizable nitrogen in the more diverse systems, decrease in bug density, increase in aggregation stability, microbial biomass. So we went back and looked at 30 years of data, and the diversification benefits overall is 9.6 bushel per acre in the till, 6.8 bushel per acre in no-till. If you compare a corn soy system to a corn, oat, barley with different red clover cover crops. Now in 2012, during a dry year, the diversification benefits is actually much more. If you had a no-till system, you were yielding 26 bushel per acre more in this dry year compared to a corn soy. And 14 bushel per acre in a till system, which is very significant when prices, corn prices are up during droughts. So we analyzed 30 years of data and found that yield stability significantly increased when corn and soybean were integrated in more diverse rotation. It was interesting because it increased the probability of harnessing favorable growing conditions as well, while decreasing the risk of crop failure. So it seems to be a win-win situation. And in hot and dry years, diversification of this very simple rotation and reduced tillage increased yield by 7% in corn, by 7% in corn and 22% in soybean. So those are some very quantified metrics of the impact that diversification and greater soil health can have on drought resilience. Now we were, well, what if we stress those systems out? Let's try to push the boundaries a little bit. So we went and put some rainout shelter in our corn rotation across a diversity gradient. We found that yield increase with healthier soil across water treatment. So you have corn soy, corn soy wheat, and corn soy oat barley with red clover. But we also found that yield loss due to drought decreased. This is the yield under drought relative to irrigated. And we found that the stomatal conductance, the impact on stomatal conductance also decreased, resulting in smaller transpiration reduction due to drought in healthier soil. Now, this is the Midwest, temperate rain-fed system, high carbon sink, focused around 2 summer crops. How does that translate to our systems in California, where we are irrigated, low carbon sink, and a very large crop diversity? So I found a mentor, a grower mentor in California named Scott Park, who let me play in his field and let me play with irrigation water and try to kill his tomato crop. Very kind of him. And he has a neighbor who they are competing with each other, and he also lets me play in his field. Scott has very healthy soil. Here we got some metrics. He's certified organic, apply compost every year, brew his own microbes in his bathtub, has yearly cover crops and a 6-year diversified rotation. And his neighbor Jake has a less healthy soil, conventional, doesn't apply compost, no cover crop, and just grow tomato, cotton, in general, and sometimes it's just monocrop tomato. Same variety, same soil, same irrigation, so kind of a very nice comparative system. So we went there and measured soil water holding capacity. Scott's soil can hold way more water. And then we started to cut irrigation at different time points, try to stress out those systems in a replicated fashion. We found that Scott used way less water than Jake, and that when you start, this is the water productivity in tons of fresh weight of tomatoes per acre foot of water applied, that yield loss in Scott's organic systems were lower when we started under deficit irrigation and leading to an increase in water productivity overall. So we're doing a lot of research, and I didn't want to show you what we're doing on the mechanisms because I'm not sure quite yet what's going on. But what I'm sure of, it's not just a soil-centric impact. Plants respond dynamically to the shift in soil health. Rhizosphere communities are different. Rooting depth is different. So we do have this interaction between the plant and the soil in these systems. And so when we were playing in Scott and Jake's field last summer, I was roaming the field with Scott, and Scott told me, I don't understand why I don't have any leaf hopper. I don't have leaf hopper, I don't have beet curly top virus, and Jake across the road has a lot of hopper and beet curly top. What's going on? So, well, the same variety, same planting date, you're just across the road. Maybe it has something to do with soil health and this ability of soil to suppress pests, which is very well known for soil-borne disease, way less for herbivores. So we took a leaf from Scott's field and Jake's field, bring them back to the lab, grew some leaf hopper, which is not easy for a plant scientist, and asked the leaf hopper carrying the beet curly top virus to choose between those two leaves. And they prefer to set up on Jake's tomato leaves. So they go preferably to the conventionally grown plant. Couldn't believe it, repeated the experiment 10 times, still happening, still couldn't believe it. So went to 3 other farms, same pattern, 3 other bird farms, same pattern except at the Funk brother, but it was kind of a funky site. We're like, what is going on? So we started to play in the lab and we're like, well, what aspect of soil health could be involved? And so we started to extract a soil slurry to be able to separate the biological and the chemical from the physical. When we applied the soil slurry from those 2 soils onto tomatoes, we still had the effect, and the leaf hopper still preferred the conventionally grown leaf. Means that something is going on with soil microbes. So we autoclave the soil slurry. Let's kill those microbes. Turns out that we lost the effect. So it seems that soil microbes and community composition are very important to mediate a resistance to herbivore. So what's going on in the plant? So we measured different plant hormones and defense hormone, and we found that Scott's plants had higher level of salicylic acid, and when you kill those microbes, you lose the effects as well. So this is just the tip of the iceberg. We've since then sampled 10 more fields, and we are playing in the lab with different filters. We're sequencing the microbes, and we're trying to see, using multivariate analysis, what are the drivers and the main management practices which are instrumental to build up resilience to leaf hopper and the beet curly top virus, the vectors. So, yes, healthy soil provide ecosystem services which are critical to build resilience and decrease vulnerability to a lot of stresses which might happen simultaneously in the field. We're looking into the mechanisms because they remain quite elusive. Now, if we think about our scale of diversification, this is across a biodiversity carbon input and its impact for them to meet our mitigation goals. We were still pretty low on the diversification spectrum. We're no-till, cover crops, but we were not really pushing the limits that agroforestry is. And the policy environment in California and our landscape was started to be very conducive to build up and look into those much more diverse systems. So we set up on a quest to identify more diversified farming system in California, which led to getting off the ground this California Agroforestry Network, which has 2 members, my colleague and I. So it's new since last week. I'm not kidding. So we went around and got a team of talented, engaged undergrad to kind of find some growers who are pushing the limits. We found growers growing cover crop in vineyards and orchards, some growers growing leafy greens and tomatoes, under walnut eggplants, under, I'm not sure what that tree is, and some multi-story cropping systems on diversified small farms. And one of the systems that came coming up are systems where livestock is integrated. We found grazing on crop residues, especially in Northern California, grazing on cover crop within cash crop rotation, pasture irrigated pasture in rotation, and grazing of understory vegetation in perennial system. Mind you, those are not very common, but we did find some growers who are integrating livestock. And one of the most prominent system was actually grazing in vineyards. This is grazing a 1,000-acre at Bonterra organic vineyard. You can see the sheep roaming around. So this has burned during the wildfire, but sheep are actually grazing still as I speak. So we set up a small group of people and basically 3 very novel growers, Shannon Ridge, Robert Sinsky Vineyards, the Napa RCDs, and 2 of my colleagues at Boston University and Community Alliance with family farmers. And we decided to study the impacts of sheep grazing on soil health and other socioeconomic outcome. When you talk to growers who use sheep in their vineyards, they will tell you the advantages are mostly operational. It helps terminate the cover crop, it helps control suckers coming out in the spring, so decreasing labor costs, and also help manage under the vine for weeds, which is very difficult to do mechanically. Now, this was very anecdotal, a lot of uncertainties, and other ecosystem services are unknown, socioeconomics outcomes are unknown. So I went and looked for funding to do that, which is not a simple task. Actually, the sheep growers were interested and said, well, we want more sheep grazing in vineyard, but we don't know what it does, so we're going to give you money, a little bit of money, to get this going. What did studies showed in the past, where we have very little literature on the topic? One of the most relevant studies looking at different cover crops, fertilization management, and different harvesting regime, grazing at 2 different times, or on grain straw in a vineyard, showed some additional benefits of grading understory compared to just cover crop. Mainly increased available P, increase in water-soluble carbon, and higher moisture retention. So we started this project a couple months ago. We are interested in quantifying the impact of sheep grazing into vineyard systems on soil health, soil carbon pool, and long-term sequestration. assess the benefit for input use, but also stress resilience. I was fortunate enough to find some growers who've been grazing their vineyard for 10 years and who have agreed for me to do some deficit irrigation trials so we can still push the boundaries a little bit and look at resilience. We also want to identify trade-off for production and soil fertility, and then through collaboration with a very talented socioeconomic Rachel Garrett at University of Boston, look at economic performance and grower perception to really understand the main barriers to adoption. So we can feed back the information to policy support to inform policy program. We're doing a survey approach, so surveying in the landscape some paired site, but also setting up a long-term trial. Again, those long-term trials are very important. If I start grazing for 2 years, am I going to see the benefits? Probably not. We need to keep this going 5, 10 years, 20 years. So we are setting up a long-term trial at the Wichita Creek Sustainable Demonstration Vineyards across a long-term management gradient which has already been established. So there's 20 years of till, no till, compost, no compost, and natural vegetation versus improved forage. So we're going to overlay sheep grazing on top. We think that manure and urine deposition coupled with additional crop and forage residue, this grazing and increase in resource allocation to the roots, coupled with reduced soil disturbance, will increase biomass and diversity of soil microbes and in turn impact the physical protection mechanisms and formation of soil organic matter, with impact on soil fertility, nitrogen retention, increased water conservation, erosion, and long-term carbon sequestration. And I am emphasizing long-term carbon sequestration because of the next step of things we're trying to do with this project, which is adding value to the wool based on the carbon sequestration potential of this sheep grazing. This wool, through the fiber shed, is being trademarked as climate beneficial. We just signed a memorandum of understanding with North Face. You can now buy your California beanie made out of the wool of the sheep, which has been grazing in those vineyards. We're putting a carbon cost on this piece of textiles to grow value for wool producer across the textile industry. This in turn will help intensify grazing in cropping system by supporting grower. A percentage of the total sale of those climate beneficial wool from North Face is going back to growers and grazers for implementation of grazing into cropping systems. So we're really trying to engage the consumers. There was a very high demand for climate beneficial garments. And I feel very fortunate to be able to put a carbon value to that. So in conclusion, we have current trends in California that provide an unprecedented opportunity to develop more integrated, diversified system. We have more perennial in our landscape. The drought and shifted conservation practices have incentivized rangeland conversion to cropland. This is this portion here. Rangeland is mostly being transformed into vine and orchard crops. It very complements other climate beneficial practices, and we have the development of a service-based animal grazing. So we're playing matchmaker right now to get this going, and the new regulatory context is very appropriate too. But we need to shape a research agenda to develop best management practices. We need to work more on design of this appropriate fostering spatial and temporal interaction. Taking a systems approach, most of the time I find that I'm too narrow. I need to look at the system at the scale at which growers take decision. We can help address some of the challenge inherent to developing more diverse and managing more biodiverse systems through grower network. And we definitely need to work on the implication of integrated crop livestock system on food safety. I chose to work in vineyards, so I don't have to worry about it. But at some point, we're going to have to look closely at those issues of food safety, integrated fertility management. Are the crop and breed of animals and system design adapted to those integrated systems? Is there some potential trade-off for soil health? I'm thinking of compaction, et cetera, et cetera. So the aim is to create some climate-smart production system that sequester carbon, reduce nitrous oxide emission, adapt and build up resilience. Soil ecosystem services are the basis for improvements thanks to the co-benefits they provide. And we think that those little guys can help. With that, thank you.